I will present you the issues at the Austrian Danube with riverbed degradation and related ecological deficits. The Danube originates in the south of Germany and passes Austria, Slovakia, Hungary, Croatia, Serbia, Bulgaria, and Romania on its way to the Black Sea. It is Europe's second longest river and the longest inland waterway in Europe that connects via the Rhine-Main-Danube Canal the Black and the North Sea. The problem area begins in the east of the Austrian capital city Vienna and ends at the Slovakian capital city Bratislava. It is about 50 kilometers long and the last free-flowing area in Central Europe without dams for water storage. The stakeholders in this area are the power plant company by storing water at the storage dam Freudenau in Vienna, where this scene was filmed. The National Park Donauauen along the whole area with its wetlands and unique Danube river habitats. The modern navigation system by transporting goods all over the world. And the population using this area for their leisure time and sports. When we look at the geological structure, we can see that only about 2 meters of the tertiary basin gravel sheet are left. The next layers are mostly made of silt and clay, and they would not be able to form a proper riverbed. At the river Salzach, this riverbed breakthrough happens after a 100 years flood in the year 2002. As a result, the water level was fallen by 2/3. If this would happen at the Danube, all the stakeholders would be affected. The problem begins at the storage dam Freudenau. By producing electricity, the water can pass, but gravel will be stored. This is also a problem for the power plant itself, because it displaces water. So they need to excavate it and dump it with machines. At the other side of the dam, riverbed degradation starts, because there is a gravel deficit. For this reason, the power plant owner is committed to fill up to 200,000 tons per year of gravel into the Danube. But the Danube riverbed is still degrading by 2 to 3 centimeters per year. And according to this, also the water level declines. The water level is the most important problem at the habitats in the national park. Not enough water arrives at the wetlands, connections to the river get cut, and finally the wetlands will fall dry because of low water. This castle is the National Park Center. It was built in the 12th century as a water castle. The Austrian Emperor used it as hunting lodge. The National Park was founded in the year 1978 to protect the habitats at the last free-flowing area. Thus the plans to build another dam for electricity couldn't be realized at the wetlands. River engineering is used for flood protection and navigation. It trains the river course, characteristics and flow. And it is another reason for higher transport of gravel by increasing the shear stress of the runoff. This training walls reduces the input of gravel from the banks. Groins at the mean water level direct the runoff to the center of the river. So the shear stress will be forced at the riverbed and more gravel can be transported. The effect of cutting oxbows and straightening the river course is useful for the navigation, but it also raises the energy slope of the river by reducing the length at the same difference in height. Once again, the shear stress at the riverbed will be forced, and once again, more gravel can be transported. Modern river engineering concerns measures for riverbed stabilization and river restoration. In early 2002, the integrated river engineering project on the Danube to the east of Vienna was started by the Austrian Federal Ministry of Transport. The interdisciplinary steering committee includes representatives of the Danube Floodplain National Park, as well as experts from the fields of hydroengineering, ecology, inland navigation, and regional economy. There were 4 principles created: bed improvement and water level improvement, habitat improvement at the national park, navigation improvement by reconstruction of control structures, and pilot testing and model testing. To halt the deepening of the riverbed, the so-called granulometric riverbed improvement adds coarse gravel with a green diameter higher than the average diameter of 30 mm. The increase of the minimum fairway depth at Danube reference low water will be achieved by the conception of regulation structures, such as groins and guide dams. Bank restoration and side arm reconnection are planned to improve the water supply situation of National Park. Draining walls will be largely removed to restore the original dynamics of the floodplains.